We're doing a combined talk because we both submitted a talk about doing Ceph on NVMe. Well, we said, well, shall we just combine the two talks, get the information in one talk and give you the best information you can get from the real-world application of Ceph on NVMe?
So my name is Piotr. I'm working for OVH in Poland, and I'm a software developer, but I'm also focused on Ceph, on providing assistance with operating the Ceph cluster. When something goes wrong, I jump in and help the team to fix the issues they are encountering. And Wido?
Yeah, so my name is Wido Hollander. I've been working with Ceph since 2010. I think it was 2009, but I don't remember. It was somewhere around New Year when I discovered Ceph about 9 years ago. And I've been working as a Ceph trainer and consultant ever since.
So the agenda for today is first of all, is the Ceph right tool for you? Because it might not be the right tool for you, or it might be. It depends on your use case. Also, if you decided to use it, then plan ahead, define KPIs for the Ceph cluster on NVMe storage, talk to vendors, and benchmark your cluster to get the most performance. You will need also to tweak it a bit. We are also going to provide some sample systems, so you can think about what you should get to get the most of your money. So is the Ceph the right tool for you?
Yeah, so there's a big thing. I see happening in the field that people deploy Ceph because they think Ceph should solve all my problems. But before you start implementing Ceph, think about, is it the right tool for you? And one of the things is, we saw it with the survey from last year. I just mentioned it to Piotr, saying 62% of the people say we want the focus to be on performance with Ceph. If I ask somebody here in the audience saying, do you want more performance? Everybody says yes. But are we willing to pay for that performance, either in price or something else? And one of the things Sage mentioned this morning is, Ceph is about consistency for data. If we want to have more performance, yeah, we can cheat a bit and we'll get more performance. But in the end, consistency of data, might not be the most sexy topic, but losing data, but you have a fast system, well, that's difficult to explain to somebody afterwards. Customers, everybody always say, it should be faster, should be faster, should be faster, and they just assume it's consistent and your data is safe. So keep it in mind that if you choose Ceph, it's a consistent system, and we will try to be as fast as possible with Ceph.
To get the best of your money, you should plan ahead. You can't make rushed decisions. You can't just go and rush through the shops and get any CPU and NVMe drives on the market and call it a day. You won't get the best of your money or your hardware at the same time if you do it that way. You should plan ahead. You should consider also all options, even those that are unrealistic at the time. For example, lately, AMD has came back into play, and they have shown that they are capable of producing processors that are able to provide enough of performance to use for Ceph on NVMe. There are also other NVMe vendors than just Intel or Samsung. So just look around. Maybe you have some other options just waiting for you to check them out. You need to specify your load, meaning number of clients, how they are going to use your cluster, what's also the desired capacity of your cluster, because this is also related. If you need more capacity, you might need to spend some more on NVMe drives. You might need to get larger drive or more of these. So speaking of capacity, this also relates to the performance of your cluster, because if you get too much of capacity per node, you might get not really best performance, because you will simply overwhelm your machine with the requests. You need always to talk to vendors, because they might have something special just for you. Speaking of KPIs, key performance indicators for your cluster, you need to be certain that you will get them wrong. But what you should consider, for example, IOPS, latency, bandwidth your clients will produce to the cluster, how many clients you are going to serve, Or what's the recovery impact when the drive fails? What's the impact for the customers, for users? What's the SLA? What's the SLA for the cluster? How much downtime you can accept? And of course, the real usable capacity.
Yeah, I think that indeed recovery impact is something which is usually underestimated. Is we always assume systems are online, NVMe has infinite performance, so we can use everything we want. But be realistic, planning ahead, do testing, and actually test those recovery situations to see if it's still onto par with the performance you expect during production. Otherwise, it will be a very bad day or a bad weekend for you if the drives start failing, if stuff just goes down and performance is horrible and customers start complaining, or inside or external customers.
So when defining KPI, you will get them wrong, as I said. So what can go wrong in specifically? For example, we have picked 240 random read-write IOPS, and we couldn't achieve that because we were CPU bound, and we couldn't imagine that at the time. So picking too much IOPS is one of the issues. Other issues like underestimating what customers and clients can do for you. Like you are announcing new offer, like we have NVMe storage now. And what happens? The customers will come and just do a lot of benchmarks, killing your storage because, hey, it's NVMe storage. I can do everything right now, right? No. So customers need to be aware of this in some way, and you in particular too. One issue that can go in the way is that sometimes managers don't listen to you. It doesn't matter what's your seniority level or role in the company. They are not listening to you, and they're just requiring you to put more capacity or something else in the cluster than you know it will handle, resulting in clusters that are less than optimal in their performance. You need to be aware of this situation and be prepared for this, and you need to be assertive. Also, if you are already talking to vendors, they might provide some benchmark numbers. You need to make sure they are valid. You need to benchmark your hardware once you get it, so you know that it's up to spec and you are getting what you have ordered. And even if you assume you have a desired number of IOPS, you are still getting clients complaining for performances. Why? Because you forgot about latencies. You are getting 300,000 IOPS, but who cares when you get 100 milliseconds of latency per IOP? So speaking of talking to vendors, you need to precisely specify what you need from them. IOPS, latency, node count, price. Price is most important in our case. If you don't specify what you need, they will provide some default numbers or something that you won't accept for some or other reason.
Yeah, so latency is something you should focus on. We stated it a couple of times and verified those claims from vendors. Of course, Intel, AMD, Samsung, they all create beautiful products. They have beautiful benchmarks, and we have a few of those coming up. They claim some numbers, but verify those claims for yourself. Just don't read the white paper, because there's always a small asterisk down somewhere stating all the things which they did, and they try to cut corners on those things. So be realistic, verify their claims before you go into production. So verify those claims 4 times before you do something with it.
This is very important. So if the vendors are cheating, then how they are doing this? One of the most common cases are using replica factor of 2.
Yeah, and this is one of the worst things which you can do with Ceph. Who is running replica 2 with a Ceph cluster? I see one. I know you are. I see another hand. Okay, who doesn't dare to put up his hand but is still running replica 2? Yeah, there we are. There we are. Yeah, it's dangerous. It's dangerous, but you'll see that vendors do this because it boosts their benchmarks. So we have some benchmarks later on showing the difference between 1, 2, and 3 times replication, and yeah, there's a big difference. So your manager will tell you to say you should use 2 times replication. It's faster. Customers want more performance, but then when stuff goes wrong, when drives start failing, lose data, well, then you're the one to blame because you built this system. It should be reliable, right? And I had a talk before on the conference saying 10 ways to break your Ceph cluster. Well, replica 2 is one of them. So under no circumstance use 2 times replication. Always use 3 times replication. And the other thing you'll see is that people will start focusing on bandwidth with NVMe. Suddenly we start putting 100 gig networking each individual machine because those NVMe's in that system, they can saturate the network. But latency is what matters. What I see in production with systems, they might be doing tens or over 100K IOPS on a system, but it's not reaching 10 gigabits at all. So if you look at the vendors again, they create these beautiful white papers with 100 gig networking. You'll be spending a lot of money on networking, while the stock switches you take are more than enough. 10, 25 gigabits per node is usually sufficient, and just tune down the backfills to prevent saturating the bandwidth. Instead of going all the way crazy, we're trying to do recovery within 20 minutes. You can do so, but you'll be spending a lot of money on network, while I recommend just buy a few more machines. You get more capacity and you get more performance because we are a scale-out system. So be cautious with spending too much money on bandwidth in a network.
Other things that vendors are using for chaining are like adding paths with caching drives. They are saying that you should use caching drive even in front of NVMe drives, or using insane Ceph configuration that's totally unrealistic, incapable for running in production, and that's configuration that's guaranteed to trash your data at some point. But they are using it. One case we had at OVH actually was when we were almost screwed because we had an NVMe drive failure. It was a cascading failure. We had actually 2 NVMe drives lost, and they were hosting the same state of data. In other words, we lost 2 replicas, and we weren't completely screwed because we had last replica living.
And I've seen these cases happening too much. So again, don't use 2 times replication. You will lose data at some point.
Never for replica 2. And this is the graph of showing the performance across different client count from 15 to 240. And as you can see, the yellow line denotes the replica factor of 3, and the white line is a replica factor of 2. As you can see, it's almost 50,000 IOPS more than replica factor of 3. And if you go to replica factor of 1, it's absolutely insane, over 350,000. But who cares about performance when you don't have your data because you lost it? Important thing that Wido also mentions at his presentations is that you shouldn't copy vendor config just because it asks you for this. Most of users don't know most of the Ceph options. Some users actually just deploy Ceph cluster using existing tools and don't think about configuring Ceph, because why should you? You shouldn't actually. So sometimes vendor comes by and asks you, oh, why won't you put this line in the config? It will make your Ceph cluster fly. Maybe. It might also cause your data to vanish one day.
Yeah, so like disabling your CephX, and now you're like, it's already, the Messenger v2 supports encryption of data on the wire, but probably the vendors will tell you to disable all that stuff because it hits your performance. But again, safety of data is something which is important as well. So while NVMe can provide all that performance, again, there's a trade-off between performance and safety or consistency of your data.
And why you shouldn't put a caching drive in front of NVMe drives? Because NVMe drives are very fast already, and actually Ceph at this point, we are hoping it will fix it in future, can't utilize NVMe drives to its fullest. I think even QLC drives are not easily beaten by Ceph. So if you are putting some kind of drive in front of NVMe drives, you are risking that if that caching drive fails, you will lose all NVMEs behind this caching drive. And on the other way, if you are going to lose an NVMe drive, the rebalancing process and then recovery will cause your caching drive to get trashed and won't give any speed benefits. So it's, in case of NVMEs, it's simply useless. You need to verify clients for very simple reasons.
Yeah. So again, it's not about bashing Intel, because again, Intel makes great products, but they do benchmarks with NVMEs, and then you start looking at their numbers, and they achieve 1 million IOPS, and you're like, whoa, 1 million IOPS? Who doesn't want 1 million IOPS from just 5 servers? And then you start looking, because those were at the really small bottom part of the white paper, and they are using CPUs, which are 10K per CPU, and they're putting 2 of those CPUs in a single machine. And I did a calculation that their 5 machine cluster, which they did with the benchmark, was roughly, well, nearing 200, 300,000 euros for just 5 machines. And the raw capacity was tens of terabytes. That was about it. Well, who's going to spend 200K in euros on 20 terabytes here? Nobody. Nobody. But you'll get 1 million IOPS. That's what you want, right? 1 million IOPS for... It is very expensive, so verify what the vendors tell you. They will use the fastest CPUs they have, the most expensive CPUs. They'll go for the fastest and most expensive NVMEs and the most expensive network, and they'll present you brilliant numbers while using Replica 1 or Replica 2. But be realistic, read those white papers and translate it to something which your organization, instead of just buying what they recommend you to do. We have a few systems coming up which we think are affordable NVMe systems which you can use.
And speaking of verifying claims, we were asked to use some expensive drive, 9900 FTVA for metadata storage, claiming that it will improve our performance so considerably that we are going to shell out every money we have just to get that performance. And we actually get one of these drives and tested it ourselves, and the best we got is 8% increase in one single case. It was because we weren't I/O bound, we were CPU bound, and having faster drives doesn't help in this case. Speaking of slower drives, we had a case of NVMe drive that had very weird performance characteristic, and we couldn't tell why is it happening. Instead of sticking to the drive, we tested the drive directly with file, with a QDEF of 1, and we realized that there is some technology behind it to improve temporary write performance. So for about 3 minutes, we had about almost 300 megabytes of write performance. And it was write performance that was considerably faster than read, which is weird, but actually quite insane. And after that time, the performance dropped below read speed. So we just discarded the drive and went with another one. And our performance issues went away. What should you use for benchmarking is mainly file, because Radius Bench is good for smoke testing to make sure your performance is in line with your expectations, but it's not for the proper testing, because one important thing, default options for Radius Bench are 4 megabyte writes, and this is not testing your NVMe drives, but network performance.
Yeah, so to add there, if you use the Radius benchmark, use it with a single thread, and then set the -O and -B flag to 4K, so that you're testing with a 4K write in a single thread, because then you're testing the latency of your Radius system writing, because otherwise people are just cranking up the amount of threads with the Radius bench and still using the default 4 megabytes, and they'll be telling their colleague, whoa, we're reaching 100 gigs of bandwidth right now. Yeah, but the latency might be super high, but you're not noticing it. So test with a single thread, with a 4K write, see what the performance is you're able to get. And nowadays you should be able to get something below 1 millisecond for a 4K replication write with 3 times replication. So a 4K write somewhere around 0.7, 0.8 milliseconds on NVMe, which is affordable.
How to run file benchmarking is quite important because you should make sure it's at least 10 minutes with some warm-up, because 1 minute will not give you the real performance characteristics. There are some issues with that, because there are some caches in the way that can be filled very fast, and then right performance is taken over. Another thing is that you should repeat the testing at least 4 times, because 1 time is definitely not enough. You should actually discard the first number, because it most of the time is inflated for some reason, which I will mention later. And you should also try your destination workload, but also different workloads, like different queue depths, operation sizes, and so on, to get a better view of entire spectrum of your cluster performance.
Yeah, so to add to this, because it's on the slide here saying precondition your RBD, because everything inside Ceph is thin provisioning. So if you create an RBD image, the actual Rados objects do not exist. So when you start writing for the first time to that image, it will need to create all those objects inside Rados. So every time you write, there's an overhead, there's a small pause while you're writing, and actually the OSD is creating the initial object. So that's allocating something on RocksDB inside BlueStore. It takes time. So fill up the RBD image first, and then start benchmarking it. And that's why you should always run the benchmarks multiple times, so that you have a realistic number instead of waiting for the object creation inside Rados.
Also remember that you should use single image for single client, because by default RBD images are using exclusive lock, and when you are using more than 1 client per image, your performance will tank. Remember also to use multiple client machines, not virtual machines, not clients like running file processes in single machine, but physical machines. This is why. This is 5 nodes of running the benchmark. These are the clients, and they are doing over 5,000 IOPS right now. As you can see, their CPU usage is actually maxed. It's maximum. Cluster could easily go faster. You could get more IOPS from this cluster if you had 1 more client. Speaking of tweaking.
Yeah, so at the networking, look at the MTU. That's a very common thing, less packets per second going over the NIC, that's better. And one of the things we wrote here is saying that, I'm not going to name it all, but right now Spectre and all the new stuff, there's so many names for it, is super hot. And if you are just running the OSDs themselves on just that machine and nothing else, you might consider disabling all those mitigations for the CPUs, because it's only the OSDs running on there. And this is something you need to decide for yourself if you trust it to do it, but they do have a performance impact having those mitigations for the CPUs enabled, because yeah, of course they were performance cheating at some points. And a few things, use recent kernels, because especially with the new Xeon CPUs, the scalables and the AMD EPYC, you need a recent kernel which has the proper support for that CPU. I've seen differences when I was testing with Ubuntu 16.04, because I was testing last year. I didn't get a really good performance with the Intel Scalable, and then I figured out that if I would go to then the 4.15 kernel, which was an 18.04, but I was testing before 18.04 got out, there was a huge performance boost with just going for a new kernel. So especially if you're using new CPUs, make sure you have a recent kernel which has the support for that CPU. And especially when you run with CentOS, it's sometimes difficult to see what they actually backported to their kernel. So verify with some different kernels to see if you get a better performance, because it might just be due to support inside the CPU. And I don't think the C-state pinning, this is something which is very unknown to people. Make sure you disable all the power saving for the CPU. Have it running on the highest clock speed at all the time, and pin it to C-state 1 or C-state 0. I'm not going to go into the C-states themselves, but you'll see a huge improvement. If you take a stock CPU configuration, as I was testing with Supermicro systems, I had a 2.5 to 3 milliseconds write latency for a 4K write single thread. After changing the CPU states, doing a bit of Ceph tweaking, and having the power saving disabled on the CPUs, the latency dropped below 1 millisecond. So going from somewhere around 3 milliseconds to below 1 milliseconds by just going for the CPU tuning and a bit of configuration for the OSDs, but not that much. So look at the CPU tuning, that's very important because we are CPU bound with NVMe.
Speaking of the mitigations for the recent flaws, here I would like to show you some impact that you can expect from disabling the hyperthreading and other forms of SMT. It's around 20% on loaded clusters. So if you are going to disable hyperthreading, this is what is going to cost you. Around 20% of performance in both IOPS and latency.
Yeah, one of the things I mentioned about with the CPU, if you disable all the logging inside the OSD, it might sound weird, but just generating the log line in memory, just compiling that log line and maybe even keeping a memory or writing it to a file, it takes time for the CPU. And it's all done within a single thread, so it just takes it eats up your latency. Disabling all the logging for the subsystems inside the OSD will drop your latency with about 10 to 15% by just disabling all the logging. You'll go blind, you'll be dark because the OSD will be silent in its logging, but you get more performance. So again, it's a trade-off which you have to make. Do I want to have a lower latency and then trade off not having any logging? Or do I want to have the logs, but then I'll be trading in a bit of performance because my latency will go up because the CPU is busy with this. Especially if you have debug OSD on 20 or something, you'll kill the performance of that OSD. You'll totally kill the performance. So this is something worth trying, disabling the logging on the OSDs.
And you can do it at runtime.
Yeah. What I usually do is when stuff goes wrong, then I enable logging, then I start searching what happens, and then I just silence all the logging again to get the latency down to what we want to have, the lowest possible latency.
Another thing you can tweak when you are expecting a huge load on the clusters, you can tweak the OSD op threads. I'm going to just go quickly over this, but the general idea is that you should use correct number of the OSD op threads, and it's dependent on the CPU you are using. Actually, the number of cores you have. If you have more cores, you can use more OSD op threads. If you have less threads, less cores, you should use less cores, because if you are using too many OSD op threads, the context switching will kill performance. If you are using less than optimal number, your Ceph OSD will wait for available OSD op thread to process operation. And for example, on one specific CPU, we decreased the default number of OSD op threads from 20 to 16, and we observed, as you can see by the yellow line, a performance increase. As you can see, it's a free upgrade. Speaking of latency, it didn't change much, so it's mostly related to IOPS. Another thing you can try to change is async op threads, because by default this number is set to 3. But this number is actually a safe bet. You should keep it at that, unless you have a slow CPU that struggles to process the incoming operations and you are getting a lot of weights on the sockets. As you can see by this, we decreased number of OSD op threads and to 1, and performance has tanked. We increased it to 12, and performance was also bad. So 3 is the safe bet. You shouldn't change it unless you know you need to do this. You can also try using Mimic instead of Luminous, because Luminous has performance disadvantages. I will show in a second how big this disadvantage is. But if you are going to try Mimic, you can be tempted to try Nautilus. You can, but in our observations, it's quite new, and you might need to do some proper validation whether it is stable for you enough, and so on and so on. When I was doing the testing, it wasn't even out, so I wasn't sure if it's going to meet our needs. So we decided to stick to Mimic. And speaking of Mimic performance, you can see it's about up to 28% performance increase when you going from Luminous to Mimic alone. So I highly recommend going to Mimic.
Yeah, a quick question. is still on Luminous? Okay, who's running with Mimic in production? Okay, who's something still pre-Luminous? Still way... okay, well, that's okay. Anybody running Nautilus in production yet? 1, 2... Daredevils, okay.
Another thing when you are picking the CPU, you should take care of is the CPU frequency trap. Because some people believe that you should get the fastest CPU you can get in terms of CPU frequency. It's not true. As you can see by this graph, we are standing between 1.5 and 4 gigahertz in all cases in different architectures, but we are going up in terms of performance. We are not speeding up, but we are going up. To make this even more striking, here on the right you can see the graph of some CPUs. All of them are at 2 and 8 gigahertz, and they have totally different benchmark scores. So why is this happening? Because CPU performance doesn't rely on CPU frequency alone. Important factors are also architecture, cache sizes, and their performance. Clock speed is, well, thermal budget. This is important to notice that thermal budget also plays a key role in CPU performance, because if you are going over the thermal budget, it will downclock or not get a maximum turbo speed, which also differs between processors and architectures, and also software, because some software doesn't utilize some instructions, others do, and they get a performance boost from that alone. So now you know what you should take into account when choosing components.
Yeah, so a few things you could look into is, one of the things which is not very much known is increasing placement groups. So I'm not going to go into it, you could Google for PG contention, and I think Nick Fisk has a good talk about this. It's, you might want to scale out the amount of PGs so that you get more threads inside the OSDs, and that way you are able to fully utilize your NVMe, but still you will be CPU bound. And then again, it might be better to go for bigger NVMes because you'll get more chips and they'll be faster than smaller NVMes. But don't go with too big NVMes, because otherwise you have just this big lump of storage behind an OSD or behind the CPU, but you're going to be CPU bound for the performance. So again, there's a trade-off there. I think the sweet spot right now is about a 4 terabyte SSD behind an OSD.
You should also keep a note of that, what your expected load is, because if you are expecting little number of number of clients, but you need latency as low as possible, you should go for the fastest CPU as you can afford. But if you need client capacity, you should think about getting more cores instead. This is just trade-off you need to judge for yourself. You should also get fast memory. So here we have some sample systems from Intel based on like Xeon 6152 and 8 terabyte drives. So per host we are about 12,000 euros. And we have 24 terabytes of capacity per host. So total cluster consisting of 3 nodes is about 35,000 euros. And from AMD side, you can drop to 23,000 euros, having similar capacity. And another sample system is from Supermicro.
To a bit to add there, because we were talking about affordable performance, is that I run these systems. I work with Supermicro quite a lot. It's not that I work with Supermicro, but my clients, they use Supermicro. And usually the emphasis is on having affordable performance. As you see, these systems are between, let's say, 9 and 8,000 euros, 8,500 euros per system. But they do have roughly 40 terabytes of raw capacity inside that chassis. So they'll be slower than the previous systems you saw, but many of the customers which I work with, they come from spinning disks, and they want to have something which is faster than spinning disks. Or they come from regular SSDs and they want to go faster than regular SSDs. Well, these systems work really well. They will be CPU bound, that will tell you, because you can get in faster CPUs, but the price will jump. And then I will say, just buy a few more of those machines instead of going for expensive CPUs. Ceph is a scale-out system. And with NVMe, we tend to build these machines with super fast CPUs, where I would say, just scale it out. Yes, latency doesn't go down with scaling out, but you'll get more performance in general, because if you scale out your applications as well, you get a better performance, better reliability. And I think these are affordable systems. And within a year time, I've seen these drop. They started at 15K, but flash memory is coming down, and they dropped below the 10K in just the beginning of this year, because SSDs are getting cheaper. And I think that Samsung has a really good price value for their SSDs. And then the AMD EPYC actually is 1,000 euros cheaper again per system. So I recommend looking into AMD EPYC as well. It's a good bang for your buck.
Here you can see some performance benchmarks of the first two systems we mentioned, the AMD one and AMD and Intel. And I would like to note here, because it's not quite obvious, but AMD systems right now are, of course, slightly slower than Intel. It's understable. But if you look at the graphs, you can see that at QDEF 16, at 240 clients, the AMD system was capable of overtaking the Intel system in terms of performance. Why is it happening? It is happening because the AMD system had some extra cores to spare for processing operations. So if you are looking for handling a lot of clients, you need many cores. If you need to handle clients fast, you need fast cores. This is very important. As you can see here, the latency difference between the first Intel system based on the Xeon 6152 and AMD 7551P is, there is a difference, but is it that not much? It's up to you to decide which is better for you. And speaking of sample systems, we have also the price comparison. For example, you can get your price per gigabyte down to below €1 per gigabyte on AMD system. And but again, it all depends on what you are targeting for. If you are targeting for performance, or you are targeting for capacity. It's up to you to decide what's the important factor here.
Yeah, so one thing to notice with this morning we were talking about NUMA at the keynotes. The benefit with the AMD systems is it's a single CPU. There's no NUMA issues with those CPUs. So they are easier to run. Less configuration required to run with the AMD systems. Single CPU instead of having dual CPUs. So they're usually a bit easier for the admin to run with.
And you probably realized by now that there is something wrong with this graph. At the end, at the Intel 2 graph, it's a dip in the price. Why is it happening? Because my benchmarking method had a flaw. I forgot to notice that the first run had to be discarded. And some of the performance data was inflated because of the TC-malloc was called and could serve memory requests faster than later. And it simply made entire benchmarking looking suspicious. This is why you should remember to benchmark using a few runs, at least 3, maybe 4, and average the results. And remember to discard the first time.
Yeah, that's
it. Okay, so that's it from us. Do you have any questions?
Thank you. It's almost about, so we are between you and your lunch, so any questions? Okay, I see 2 hands. Let me start at the back. Yeah, you're at the back. I can't hear you. About disabling which options? The debug options, yeah. Yeah, I'm disabling to 0, yeah. No, just to 0, because if you set the debug option to just 0, it will disable the in-memory and the file logging. Yeah. So
Yes.
for the audience indeed who's going to be seeing this in the recording, the slide says debug OSD to 0, and Jao was mentioning it indeed. If you set it to 0/0, you also disable the in-memory logging of the daemon. So you probably need to update the slide saying that it says 0/0 instead of just 0. So Yeah, I disabled it with 0/0. So yeah, it disabled both, but the slides were indeed wrong. So we'll update them with the proper ones. And there was another hand in here. The 4G in the BIOS, you mean? That's Piotr. You can add that. The question is about, did you enable the above 4G
right,
encoding?
because in our testing we realized that at one machine we had this option disabled, and it caused a lot of IRQ storms, degrading our performance. I can't exactly explain what's going on here, but it's related to how memory works, and it was just conflicting with other devices in machine. So after we enabled this, the performance went up.
Any more questions in the audience? Jao, another question. No, so the question would, did I know the impact of having the debug just in memory? I haven't tested one, but I think that actually writing to the disk is not the most expensive part. Compiling the line for the CPU and processing the log line takes most of the time.
Actually, it's both are expensive, but in previous Ceph versions, the lines weren't buffered on the disk, where Ceph was just writing them to the disk, and if you had a lot of logs going on, you could pay a penalty of a lot of syscalls. In later revisions like Mimic and Nautilus, this is fixed a bit, because if you are writing 10 lines in a one go, they are just using one syscall, and the performance impact of writing to disk is lower. But in previous version, the performance impact of writing to disk is quite high. In any case, you should disable logging at all, not just to memory or just to disk.
Okay, there's one hand in the back, and then I'll get to you. In the back. Okay, so the question is how much you pay for disabling the power saving. I did some testing, but just going into the IPMI of Supermicro, and those 10U, or the 10 NVMe's, they consume about 200 watts of power continuously with the power saving disabled, and with the power saving enabled, they were consuming about 170, 180 watts. So it went up with, say, 10-15% of power usage. But our latency dropped from 3 milliseconds to something below 1 millisecond. So that's a pretty high gain you get there. There's also a setting where you can use idle is poll in the Linux kernel. That will improve your performance even more, but then I saw the power consumption go towards something like 300 watts for the same system, so it doubled. Yeah, one question here. So the question is running partitioned NVMe drives, multiple OSDs on the same NVMe. Did you have any experience? Because I don't have experience with that.
Actually, you should do this in current Ceph versions, because at this point, Ceph isn't able to utilize fully one single NVMe drive. To get most of your NVMe drives, you should put at least 2 OSDs on single NVMe. But you need to be also aware of the implications of this, because if your drive fails, you will lose 2 OSDs. But in my opinion, it's a good trade-off.
No more questions? Well. How much memory we assign to an OSD? We said, I usually say somewhere around 8 to 12 gigabytes per OSD.
12. because
Yeah, 8 to 12. He says 12. So I say 8 to 12. 12.
use 10.
Okay, 12 is fine. Yeah. Okay. Then I think it's time for lunch then. And otherwise, you'll find us at lunch if you have more questions. Thank you.
Thank you.